Okay, so let's start. All right, so everyone, thanks for coming. I'm Jianfeng Chen from Meta. So the talk of my title is Mobile Develop Toolchain for GraphQL and Meta. So in this talk, I would like to introduce our developing toolchains for mobile developers in their daily life at Meta company. So I think there's another talk tomorrow which is talking about the GraphQL IDE implementations, which may have more technical details there. So in this talk, I would like to discuss more toolchains in their whole developing process. So this is the agenda of my talk. I will first have an overview of my toolchains in the company for GraphQL mobile developers. And then after that, I will talk about the architecture in depth on how we implement these toolchains. And then we will see a very interesting workflow example by integrating with different kinds of tools to help us to improve the code quality or implement some goal for the GraphQL. Finally, we have a Q&A session. All right, let's go. So in Meta, when someone wants to introduce a new GraphQL or update some GraphQL query, they need to follow these 4 steps. So the first step is to edit their GraphQL in the IDE. So VS Code or NGS Studio or anyone's file. So they need to edit this GraphQL. And then after they edit GraphQL, they need to move to the next step, which is happening in the command line. In this line, they need to run some command to verify their changes and update the code generations. When they finish this part, they need to publish or push their code to for their peer reviews. In the peer review or fabricator process, we are doing the CI/CD test or DevOps integrating tests. After the test is okay, peer review is okay, we are going to the final step, which is launch the code to the product. This is the 4 steps. In each step, we develop different tools to help people to make their life easier. That's the first part. So in the first part, people need to edit or add a GraphQL query or change some GraphQL in the IDE. We develop some GraphQL plugin for that. So in this plugin, we support 4 features at this moment, which is the autocomplete, hovering for documentations, go-to definition, and the real-time validation. As you can see in the right-hand side, this is an example of the autocomplete, just like other programming language. This is the hovering. When you hover on some field, you can see the documentations immediately. And on the right-hand side, we bring the similar idea as the graphical. You can explore the schema as well on the right-hand side inside the IDE. This is the hovering. And for the go-to definition, just like other language as well, we are supporting the go-to fragment definition over the spread. For example, right here, people can command or control click to the corresponding fragment. Finally, we are also running the real-time validations when they are editing the GraphQL in the IDE. In this example, when people type a duplicated fragment, they can see the error below or next to that immediately. So this is the tool we are supporting when they are editing the GraphQL. After people edit the GraphQL, they're moving to the next step, which is the command line step. In this command line step, we are doing 4 things. The local validation, I will explain that later, what is more local. So, and then generate the target code, the linter, and submit for peer reviews. First of all, we provide a command to mobile developers to verify their change modules, aka local or the local validations. That means if the module is not changed or developed by other developers, this command does not verify that. And then the command line also automatically generate explore some easy use APIs into the target language. For example, when they are developing the Android, we generate some easy use or user-friendly API or interfaces in Java. Similarly, in iOS, they have the Swift or Objective-C. In this way, the mobile developers need no worry about the data fetch logic under the earth. And the API is simple and user-friendly use. The last part is the linter. The linter chat is for the code quality. So for example, something like this. We can ask people to have the FB honor directive in every operation. This is an example for the linter check. If people violate these rules, they can see the warning or errors in the command line. The linter runs upon the AST without the schema info, which is very fast. And finally, the linter only checks for the change or edit file. Yeah, this is the command line part. After they finish these steps, they can submit their code into peer review, which moves to the last step. In the peer review part or fabricator part, we are running the integrated test in the cloud 24/7. In this stage, we are doing 4 things: the global validation, sanity check for target code, linter check, and peer review. So recall that in last step, we are doing the local validation, but this step, we are doing the global validation. We need an extra validation upon all modules. This is because the meta GraphQL at this moment are not fully modularized. Your change in one module may have impact on other guys' modules, something like that. So we have ongoing efforts to make the GraphQL fully modularized. So you can please check out tomorrow's talk from Matt, Morfrey, and Dev on how we are modularize the GraphQL at this time. Okay, and then the sanity check. The sanity check is to make sure people run the code step correctly from the last step before they submit the code for peer review. We are also review the linked errors to code reviewers. The peer review and acceptance is required for any GraphQL changes. So when all tests pass, people accept their changes, they are going to the last step, which is the launch. So one final step before the launch is the merge driver. So the merge driver is for resolving the merge conflicts in case 2 people are editing the save file or changing the save file at the same time, something like that. Yeah, this is our complete workflow and supporting tools for people editing the GraphQL at Meta. So recall that, just a quick recap, they have 4 steps, and each step we have different tools or jobs for them to make sure the GraphQL is valid and easy to use for the company. Yeah. So this is the framework. And then for the last part, let's see how the architecture is implemented. So first, the Rust. So we start to convert or change our infra from the JavaScript to Rust 2 years ago. According to the Stack Overflow survey, the Rust is the most beloved programming language. This is similar to our feelings actually. So the reason why we use Rust is that, first of all, high performance. We are moving from the JavaScript. A couple of years ago, we are using the JavaScript, but we find that the response time or the build time is not very satisfying. So the Rust is a high performance language. So it can shorten the IDE response time or the code build time. The other part is the memory save. The Rust have a very interesting, helpful lifetime concept, which is help us reduce the unsafe memory leak, like the C++ language, something like that. And then the Rust have many easy to use library for the concurrency programming. We have open source the GraphQL compilers in Rust. So check out these repos or these these folders like relay/GraphQL IR or schema or relay LSP. So a quick note, although this is under the relay project, it is written for general GraphQL. So we plan to separate them from the relay library in the future. Yeah. And then with this ROS part, let's see how we implement the infra across different stages, something like that. Across all tools, we have a kernel, which is the parser and compiler. This parser and compiler is shared across all tools in different stages. So it is built upon the schema and the GraphQL IR. After that, all other tools are built upon this kernel. Here shows the IDE part. The IDE part has two sides, the server side and the IDE client side. So we are using the Microsoft Language Server Protocol, or LSP, to help us communicate between these two parts. So for the server side, we need to define or accept the changes or information from the client, and we produce the to produce the output in some LSP output format. And for the client side, we have different kinds of clients for various IDE, for example, VS Code or Android Studio. So we don't need to worry about the communication between these two sides or the context on how the server doesn't need to worry about the client side, or the client side doesn't need to worry about the logic of the server side. They are separated. They are communicated within the LSP logic. So let's see the implementations. So the GraphQL open source ROS library, LSP types provide a very convenient way to send response or notifications to the IDE which access the LSP. So this code is coming from the LSP server side. So in the server side, this is on hardware function or on hardware implementations. They have a parameter as the input. This input is coming from the client saying, okay, people are hovering on some files, for example, screen.graphql of line 23 of chart 4, something like that. And then with this information, together with the context of what the schema and the IDE content, so at this moment, you should calculate and generate the output of the hardware result. The hardware result is very direct. It is the text of Markdown format or HTML format. So in this way, the server just need to worry about the exact logic of that, and they don't need to worry about how these HTMLs are rendered or something like that. Those are the jobs of the client. Yeah, this is the LSP helping the IDE too. And similarly, we have another protocol, a method called the Meta Fabricator Linter protocol, very similar to the IDE idea. So they have the shared kernel, and then we are together with the IDE linter message generator from this source. And then given the source, pass that generate the linter message, typically in JSON output. And then after we generate the JSON, we don't need to worry about how people are rendered or how people are seeing that in the Fabricator or command line. So the Fabricator linter protocol will accept that, and the supporting tool will review the warning or errors to the public in IDE, in command line, or in Fabricator for peer review, something like that. Yeah. This is the technical side. As we can see, and we have a shared kernel, and most of the time we have two parts, the server side part and the client part. They communicate within some protocol. The server does not need to worry about how the results are rendered. And the client is typically developed by other teams, not just from our GraphQL build infrastructure team. Yeah. So in this way, we can reduce our work to develop the complete tool tree like that. All right. So this is the architecture. And the last step is that let's see a very very helpful example, an interesting example. We are going to combine the derivative, IDE, linter, validation to maintain the code quality. Let's see this example. So right now, we are asking people to claim all queries with the derivative at FB owner with the argument their team name. Let's say someone, for example, today we want all teams have this kind of a derivative in their query, but the GraphQL infrastructure, the maintenance team apparently doesn't know the context of their query, so we don't know the exact point of context for the exist queries. We hope people can claim this as soon as possible. So what should we do? A couple of lessons first. So first of all, we are introducing a new derivative called fixme missing FB owner. So for all queries missing the owners, use some simple internal code module to add this derivative in batch. This is simple to implement. We don't need any context of the query itself. We can just add that immediately. After that, we add the validation route, which invalidates the query without fixme missing FB owner or FB owner. Just a quick reminder that in the fabricator process, we have a global validation which passes all queries or the whole corpus. So with this validation route, that we can guarantee all query must have one of these derivatives. And then one further step, we add a linter route which yields the warning for the existing fixme missing FB owner. The linter rule is different. The linter rule only reveals the error warning for the changed file or new files. Yeah. So by combining these steps are benefits. So the validation rules always check for all GraphQL corpus. So for new queries, they have to add one of these derivatives, but they should add this one. They should add the FB owner because the linter route checks for the update files. So every time they update some query or introduce a new query, they will see the warning if they are using this fixme stuff, right? And at the same time, in the IDE, when they open some query with the derivative fixme missing FB owner, they can also see the warning message so that they are guided to update the derivative into the FB owner. So in this way, the GraphQL maintenance team or GraphQL build infra team doesn't need to have a context of the exact query or GraphQL sources, but we are guiding people to update to FB owner gradually. So yeah, that's the example of the workflow. In this example, we can see that by introducing a fixme derivative and combining with our validation tools, IDEs, and the linters together, people are guided gradually into adopt their new or better practice. Yeah, this is the example, right? So I will leave more time for the Q&A session. Any questions are welcome, and share your experiments. Share the experiments in your company's development for GraphQL. Are welcome. Okay, thank you very much. Any questions? Yeah. How did I define the linter rules? Okay, so for the linter rules, basically most of the time, first of all, the linter rules only load the AST of the source for single file. That means the linter rule should not have the context of the schema, should not have the context of the fragment definition. They should only have the single files there. So that means most of the time, the linter rule is for the code quality for the single file. For example, missing the directive, or they have too many arguments, their name is too long, their alias is invalid or too long, something like that. This is the linters. And the linter rules is for people maintain the code quality, not violating the other parts of the GraphQL, other modules, something like that. Yeah. You go ahead.
How do you check for validation against schema?
How can I check for against schema? Okay, so in the command line part, we load the schema for the client and save that into the memory. And then we check, for example, some people have a GraphQL query or some definition which is in referencing a missing field in the schema. They should see the error message there. So first of all, to answer the question, we have the schema in the memory, and we check that and review the error from the IDE to the IDE or to the command line terminal. Any other developing experiments in your company for GraphQL developers? Yeah, go ahead.
So we have a public GraphQL API. That's pretty interesting because now all the sort of tooling that you're talking about, we have to give out to our customers because they're the ones using that.
Okay, yeah. So I think the most important part or of our implementations are these parts. So the IR, especially for the relay RSP, there we also have the linters. We also have the validation rules under this repo. Please check out this one. We have the very detailed with me there as well. Yeah. Right, that's it. Right, thank you very much. Thanks for listening. Thank you.